William Gilbert's scientific method. William Gilbert's scientific method marked a significant shift in the approach to scientific inquiry during the early 17th century. His work laid the foundation for empirical experimentation, distinguishing it from the reliance on philosophical reasoning that William Gilbert's scientific method. William Gilbert's scientific method marked a significant shift in the approach to scientific inquiry during the early 17th century. His work laid the foundation for empirical experimentation. William Gilbert's scientific method. William Gilbert's scientific method marked a significant shift in the approach to scientific inquiry during the early 17th century. His work laid the foundation for empirical experimentation, distinguishing it from the reliance on philosophical reasoning that characterized earlier scientific thought. The shift to empirical observation. Gilbert's methodology was revolutionary because it emphasized empirical observation over theoretical reasoning. He prioritized direct, hands-on testing, which allowed him to draw conclusions based on actual experiments rather than abstract logic. Direct testing, Gilbert believed in observing phenomena directly. His experiments were designed to be repeatable, ensuring that others could verify his findings. Practical applications, this approach not only advanced the understanding of magnetism, but also set a precedent for future scientific practices, influencing generations of scientists who followed. The Torella, a model for understanding magnetism. One of Gilbert's most notable contributions was the use of the Torella, a spherical model of the Earth made from natural magnets. This innovative tool allowed him to simulate and study the properties of magnetism in a controlled environment. Magnetic behavior through the Torella, Gilbert demonstrated how magnetic forces operate, providing insights into the nature of magnetism itself. Earth is a magnet. He famously argued that the Earth is akin to a giant magnet, a concept that reshaped the understanding of terrestrial magnetism. Reproducibility in experiments. Gilbert's work culminated in his seminal book, De Magnet, published in 1600. This text detailed his experiments with remarkable precision, allowing for reproducibility, clear methodology. The experiments were outlined in a manner that others could replicate, fostering a culture of verification and validation in scientific research. Influence on future scientists, his emphasis on reproducibility not only bolstered his own findings, but also inspired later thinkers like Galileo and Kepler to adopt similar methodologies in their own work. Distinction between forces. A critical aspect of Gilbert's research was his ability to distinguish between different forces. He separated magnetic attraction from electrical effects, which was a significant advancement in the understanding of physical forces. Magnetic versus electrical, Gilbert clarified that magnetism and electricity were distinct phenomena, laying the groundwork for future studies in both fields. Terminology development. His work contributed to the development of terminology that is still used in the study of physics today. Innovations in instrumentation. In addition to his theoretical contributions, Gilbert also made practical advancements in scientific instrumentation. He invented the versorium, an early form of an electroscope designed to detect electrical charge, testing for electrification. The versorium allowed Gilbert to explore the properties of electrification, further bridging the gap between magnetism and electricity. Instrumental legacy. This invention exemplified his commitment to using tools to enhance scientific inquiry, setting a standard for future inventors and scientists. Influence on scientific thought. Gilbert's scientific method and discoveries had a profound impact on the trajectory of scientific thought. His approach not only advanced the study of magnetism, but also influenced the broader scientific community. Inspiration for future generations, his empirical methods and focus on reproducibility inspired a shift in how science was conducted, paving the way for the scientific revolution. Enduring relevance, the principles he established continue to inform modern scientific practices, emphasizing the importance of observation, experimentation, and verification. Conclusion. William Gilbert's contributions to the scientific method were transformative, marking a departure from philosophical reasoning towards empirical experimentation. His pioneering use of the Torella, emphasis on reproducibility and innovations in instrumentation, laid the groundwork for future scientific inquiry. The impact of his work resonates to this day, influencing how science is conducted and understood. Through his meticulous approach to experimentation and his ability to distinguish between various forces, Gilbert not only advanced the study of magnetism, but also set a standard for scientific rigor that continues to shape the field.